So you know those webinar replays that you watch at 1.5x? Pretend that's what you're doing now, because I'm going to go through a boatload of stuff, and I'm going to talk really, really fast. And so just imagine that's what you're doing here. So we're going to talk about why you should hack your APIs. I'm going to go through real-world breaches, and we're going to analyze them and kind of draw some conclusions there. Who am I? I'm the co-founder of APISec University. Quick show of hands, anybody heard of APISec U? All right, sweet. And some of you haven't, so now you have. It's a free site, APISecUniversity.com. We started with one course, API pen testing, that really became super popular, and now a year and a half later, we're at 75,000 students taking our courses. All free, no vendor pitch, no sales, it's just great content. You can see our list of courses, and we got a bunch more coming. So check out APISec U if you want to learn more about it. We do a lot of webinars, and as Bill mentioned, we're actually doing our own conference, virtual, May 22nd, APISecCon.com. I'll show you that again here at the end. All right, so why do attackers love APIs, right? And so this is a basic stack where you get your front end, talks to some APIs, connects to the back end. And historically, we spent a lot of time focusing on that front end, right? Where we authenticate users, filter data, we show you this button, but we don't show you that button. We do web app scanning, we do all these things, right? And what happens? Attackers go right around it, right? This happens all the time, right? And we use our UIs as kind of a band-aid sometimes for security. And when attackers go around it, they find APIs that are over-permissioned, have access to too much data, access to functionality you don't expose in the UI, right? Exposes business logic flaws and things like this. And that's why attackers love APIs. So let's go through some real examples. And Travis, I promise you there's some new ones in here. So Coinbase is a great example. This hacker wanted to play around on the Coinbase platform and see if they could find any flaws, right? Like a good hacker, they created an account, they put some money in, and started trading. Press every button, right? And they started watching the traffic between the UI and the back end and identifying all the API calls that were going on. And what you see here is the payload for doing a trade, right? Now this person owned 0.0243 units of Ethereum. And so they wanted to send some intentionally bogus requests because sometimes we get error messages that are revealing, right? So you did a trade. There are 4 parameters. What are you selling? Ethereum. Are you on the buy or sell side? Source account, target account. So this would be a valid trade, but he then backspaced over Ethereum and he wrote Bitcoin, okay? Something he did not own, right? Way more valuable, right? And he hit send and he waited for the error response to come back. And instead of an error response, he got $43,000 deposited into his account. It actually worked, right? He went on Twitter and said, does anybody know the CEO's email? Because I found a market nuking vulnerability. Actual words, you can find it. And Coinbase gets a lot of credit in my book. They immediately shut down the service for 24 hours. They reproduced the issue, they fixed the issue, which I think, as Katie mentioned, that was probably 1 line of code, right? And they blogged about it a week later, right? And they said the root cause was missing logic validation check. The app was checking how much he owned, but not what he owned, right? And that is a classic business logic flaw. And they rewarded him with $250,000. All right, pro tip, your UI is not part of your security stack. This could not have been done through the UI, impossible. There was no button to say, how do you want to sell this, right? You want to sell it as Ethereum or you want to sell it as Bitcoin? All right, that's number 1. Peloton. So here, an attacker, in this case, poked around the UI, watched all the traffic between the bike and the back end, and they found all these API calls. One of them was wide open, right? And this API had access to all 4 million users on the platform. Even if you marked your account as private, still had access. Even Joe Biden's records, right? So it was a wide open API, access to everything. And after much embarrassment, Peloton fixed it. They added security to the endpoint, added a challenge, right? Easy to create your own account, easy to go authenticate, and you still have access to 4 million users, right? So the pro tip here is, I think someone mentioned this yesterday, authentication is not the same thing as authorization. They fixed authentication, they forgot about authorization, right? All right, Duolingo, 2.5 million records lost here, right? What did they do? They found an API endpoint where if you submit an email address, it would reply and say, is this a Duolingo user? And if so, here's all their info, right? This one was so easy to do that I hacked myself. And this is real data. This is my actual Duolingo account. There's my email address. You can even do this through a browser, right? All you had to do is go to this URL, put in an email address, and if it was valid, it would tell you, I have a 624-day streak, I'm learning Italian, all that stuff. No challenge, nothing, right? So they just fired a bunch of emails and just started harvesting this information. And the shocking thing was, Duolingo didn't even think this was a problem, right? They were like, what's the big deal, right? There's no home address, right? But what's happening is they're connecting my public profile, which I didn't even know was public, to my personal information, my email. So, pro tip, your hidden APIs will be found, right? I can only imagine that the developers of this API just thought, like, who's ever gonna find that thing? Like, why would we ever use it? What's the point, right? And in the rush to get features and functionality out, so they just pushed it out. It's easy to push it out with no authentication. All right, Venmo. So this is, they had a feature on the home page that would show you the last 10, 20 real transactions. And it would strip out the personal information. So no last names, no account details, address, or any of that stuff, right? So somebody found it, as they do, right? It's a public API endpoint, no authorization, wide open, right? Now, when you call the API directly, it doesn't give you anonymized data. It gives you all the data. First name, last name, description, who you're sending money to, how much money, everything, right? So they wrote a script. And they found 207, and they harvested 207 million transactions from Venmo. Full detail, right? They even made websites to track drug dealing on Venmo using this API, okay? So, pro tip, don't filter data in the UI, right? Filter it at the source, right? Because back to like what attackers are doing. They're going around the UI, they're hitting the API directly, and if your API returns all the data, then that's what the attackers are gonna see too. Right, they should have built a purpose-built API just to return anonymized data and only expose that through the UI. All right? So those are 4 examples. It happens to map to OWASP 1, 2, 3, and 4. Right? We had a broken authorization with Coinbase, broken authentication with Peloton. Here we have excess data exposure and so forth. All right, one more. Trello, this is from a month and a half ago, right? So it's a lot like Duolingo, right? So there was an API where if I want to invite you to my Trello board, I can use your email address, send a request, and so forth. So somebody found an API that powered this, and it accepts an email address as the input, right? And this was wide open again, right? No security, no password, nothing. So you send in an email, and it will reply if that's a user, and if it is, their Trello public profile data, right? So this became now valuable, right? This public profile data, which is sort of, anonymous or whatever you want to put out there, is now connected to your email address, your sort of personally identifiable information. So what do? They went on the dark web and they harvested 500 million owned email addresses, right? And they fired them all off at this endpoint. And they found 15 million matches. And they put it up for sale. This is the posting on the dark web, putting it all up for sale, right? Now, what's remarkable here is the 500 million, right? Like, how did that not ever get noticed, right? And they talked about it, right? Like, we had a WAF in place, we had rate limiting in place, right? And it just points out, like, rate limiting is must-have, but it is not a silver bullet, right? Attackers are clever, right? They're gonna find ways, they're gonna use proxies and rotate IP addresses and do all these techniques, throttle their own requests, right? Maybe this took months to pull off, right? So there's your pro tip there. All right. So now we're going to go through all of these. No, I analyzed all of these, and we published a report that we just issued last week, and at the end you'll get a QR code, you can download it. But we looked at all these breaches, right? And what comes out here? There's a boatload of them. Right? It's not little mom and pop shops, but great big sophisticated organizations, right? And millions and millions, hundreds of millions in some cases, records getting harvested through leaky APIs, right? Or vulnerable APIs, or APIs that aren't configured properly, or rushed to get out into production, and so forth. So we looked at these and we analyze what was the root cause of all these breaches. Well, this is what we found, okay? And you look at this and you say, all right, well, my number one problem is rate limiting, clearly. Like, that's over 70%. I don't have my glasses on, but 60 plus 70% of all the breaches. There's a couple more animations for folks who are taking photos, so I'll let you know when the slide is done. And so that would be probably a fair conclusion. Like, we got to fix rate limiting. But I actually would argue that's the wrong conclusion, right? And the reason why is probably 99% of those companies had rate limiting, right? They had WAF in place. They had other detection. They had SIM and Splunk and who knows what else, right? And still, this harvesting happened, right? So it just reinforces how, while it's a critical part of your infrastructure, it's not going to protect against everything. And really, it's not the root problem, right? If there was nothing interesting to harvest, you wouldn't send 500 million requests trying to harvest it, right? The root problem is there's something interesting to harvest, right? The rate limiting just makes it worse, right? You don't lose 100 records, you lose 100 million, okay? So, all right, if you accept that, then what we found is these next three, which not coincidentally map exactly to OWASP 1, 2, and 3, right? So really, support the OWASP and their findings. These accounted for 90% of the breaches on the prior slide, right? And I do think that's the last animation, so if you want to take a picture, take it out. Or if you want a copy of the slides, email me. 90% came from one or more of these three things. Broken authorization. Can user A access user B's data, right? Or some combination, or a Coinbase. Can I sell something I don't own, right? That's broken authorization. Broken authentication. This is defined as weak or poor authentication, so like no CAPTCHA or weak password requirement or credential stuffing, all these kind of things. But that's not it, right? What's happening here is no authentication, right? Like countless times, right? The door was just left wide open. Some belief that the API wouldn't be discovered or exploited or played around with, and that happened. And then the key is excess data exposure, right? Something valuable is being returned in this response, right? And is it appropriate for the business use case, right? If you only need first name, then why are you sending last name, home address, account number, email, and everything else, right? So if you have one or more of these things, that's what led to 90% of the breaches, right? So our belief is, like, API security is a big, huge problem, and as we just heard from Dana, or Aaron, there's a ton of things to consider from a attack yourself or hack yourself perspective. Start here. Right? And it's not to say the rest aren't important. Like, you need to know all your APIs, you need to know what they're doing. But if you can tackle these, you're in pretty good shape. So then we thought about, how do you do that? Right? What's the best place to actually hack yourself or to discover these types of vulnerabilities? So we looked at kind of the API lifecycle, right? And I'm not an engineer or anything, but this is Dan's simplified view of the world, right? So you start with API definition, like, hey, we need an API that does X, right? And this is where you should all sit down and talk, right? I call this the governance phase. Like, let's just get everyone in the room and talk about it, right? And define, what are the security implications. All right, you go into development, you do your code reviews, static analysis, look for vulnerable libraries, all that good stuff, and you should do that. But that is not one of the breaches that I showed you on the prior slide. Okay, so you get into testing, right? So you got your legacy testing tools, you got your they aren't really great on APIs, then you're doing it manual, right? So you got to pen test once a year, or red team. You pen test once a year, but how often are you releasing code? 52 times a year, right? 365 times a year, that's a ton of code not getting tested, right? And this is where we think there's a great big security gap, right, between development and deployment, right? And it's not because we don't want to, it's just really hard, right? And the tools, the automation hasn't existed. And then you move into deployment, right? We are huge fans of gateways. You should use gateways. It's a great place to enforce, enforce governance and controls and the like. And then you got your WAF and so forth. All right. So then we looked at where can you find these flaws, OWASP 1, 2, and 3, right? Not to mention the rest, right? But what was 1, 2, and 3? Can you find authorization flaws in testing? Sure you can. Log in as Dan, and then try to access Aaron's records, right? If that works, you got Ebola, right? And then automate that, right? And come up with all the different combinations and permutations. Can you find authentication flaws? Especially like no authentication. Well, that's pretty easy. Go to every endpoint with no credentials and see if it works. Now you know, right? Is that by design or is that a flaw, right? Data exposure. Query everything you got and look at the data coming back. Is it sensitive? Is it appropriate for the use case that you got, right? And yes, you could do some of this stuff later on, but all things equal, wouldn't you like to learn this stuff earlier, right? Before it ever goes live, right? While the developers are creating the APIs. And so to reinforce that security gap, this is from Rapid API, stateofapis.com, their report. We're really good at testing functionality, right? Like, does the app do what it's supposed to do, right? Can I sell crypto that I own? Yes. Down here at 4% is security testing. Does it not do what it shouldn't do? Can I sell crypto I don't own, right? They didn't run that test. Okay, so how do you address it? This is my sort of advice slide, I guess. We can't rely on manual testing, right? You should do manual testing, right? It's a thing, but it can't keep up with development, right? It's not going to keep up, right? So we got to have automation in here. It needs to be comprehensive. So think about it. You got an API with 100 endpoints, and you want to test authorization, authentication, data exposure. You want to do cores, headers, and rate limiting, and fuzzing, and injections, and all these things, right? So take all those, multiply it by your endpoints, you've got thousands of permutations, right? So we've got to use some sort of clever, test generation capability, and it's got to be integrated, right? Continuous, right? If you do a nightly build, then you should be testing it nightly. You would never push code live that hasn't been functionality tested. Same is true for APIs. And one of the questions we asked in our survey was, where do you want to find your APIs, your API vulnerabilities, right? Not surprisingly, everyone wants to do it shift left, right? Why not, right? Find it earlier if you can, right? And so, little plug for my companies, we do this, right? We automate testing, we find vulnerabilities, we create the test for you. You don't have to sit there and write those thousands of tests. So please come talk to me. Remember my email address. I don't want to make this an infomercial, but please come talk to me. If you want the report, right, so we just published this report with the 2,000 survey results and the results of our breach analysis. There's the QR code, and so definitely welcome you to download it, check it out. We also provide private API security workshops. So if you want to raise awareness in your company about API risks, what I just did in 20 minutes, we do it over about an hour with a little more deep breaths along the way. No cost, all free, no vendor pitch. We're happy to do that as well. So come talk to me about that. I'll just flash for a second. We are running our own conference, so as Bill mentioned, this is all virtual. It's free, no agendas, no pitches, just awesome speakers. So we launched this 2 weeks ago, or we announced it 2 weeks ago. We have almost 2,000 people registered for this. So it's going to be a great event on May 22nd. And I'll just flash this back for a sec if you needed to get that QR code. But I think with a minute left to go, I'm all good. So thanks everyone for listening.